Ladies and gentlemen, coming up next, we are honored to have Professor David Schneider, Director of Master Engineering Studies in Systems Engineering at Cornell University, to share with us on the topic of scaling up learning competences, AI education, and edutainment. Regrettably, Professor Schneider isn't able to join us in person due to another commitment, but he's going to share with us his valuable perspectives online. So let's take a moment to explore what he has to share.
Hi everyone, and welcome to Scaling Up Learning Impact, AI, Education, and Edutainment. My name is David Schneider, and honestly, it's an honor to be talking with you all today. I've had the wonderful opportunity to work with a number of different companies throughout the world, particularly on a number of educational projects. And so today I'm going to be talking a lot about starting off with the secret of making edutainment actually work. We only have 20 minutes today, so we want to start off and make it actually worth your while. We're also going to talk about the current state of AI use in education, but more interestingly, we're going to talk about what's not being taught about AI. There's some real opportunity for us to make an impact in this area, and that's really what I want to get at the heart of. How do we make the biggest impact with any of the educational efforts that we're making in this area, and really target some fundamental design skills that are lacking in citizens around the world. And I'm going to show you how robotics and particularly computational thinking are some of the most key areas for us to make that impact with. But all right, let's start off with the secret of making edutainment work. Now, I was very fortunate in that I got to be part of the NSF grant for the creation of the field of computational sustainability. And as part of that, we actually created a number of edutainment games. And believe it or not, in these games we created, we were able to teach college-level algorithms to 12-year-olds. And I'm talking about like network flow, linear programming, genetic algorithms, and they were getting it and doing really well with it. How the heck do we pull this off, right? Because again, this is normally taught to college students. Well, the first part of the secret is you have to create a fun scenario that the player actually cares about. And I could talk a lot about player agency, but I have a feeling that this audience understands that. But some key elements in doing it for edutainment is you preferably want to create a scenario where they think that they're able to perform really well in it. And so you can form this belief that this is something they can really excel in. And let me give you an example here with Dijkstra's shortest path as one of the algorithms that we taught. Now here's a simple scenario where I've got to get a bear through this grid in order to reach the fish. That's the goal, and find the shortest path there. And so this is a fairly, again, introductory scenario where, it helps players really feel like they can do it and kind of shrug off what is that uncertainty of doing something new, particularly something new that supposedly only really smart people can do. Because again, I'm going into a group of 12-year-olds and telling them, hey guys, you're going to do algorithms. And they're like, algorithms? I've only heard about that in the movies, right? That's something that the really smart person does. But so they're going to feel that initial fear and trepidation. But I give them this initial problem, again, to help them build some success, and I slowly start to introduce additional problem elements, pieces where it might take them longer to get through, reward elements, and basically making the problem more and more increasingly complex, but still reasonably doable within their current skill set. Until finally I present them with something that looks like this. And I imagine there's some of you right here in the audience who are taking a look at this and like, hey, you know what? If you actually gave me the right information, I could solve this. It might actually be fun to do, but it still might be quite challenging. And that's just the right level that you want to start to, again, introduce some of this educational content. And I want to emphasize that it must be, still presented at a point where they feel like it's solvable. Because if it's not solvable, it feels like they're being told to do something that's unfair. And if they feel it's unfair, they're going to feel like they've been duped and they'll want to quit. But we want them to continue. So again, in our recipe here, we want to increase the difficulty so it's quite challenging, but without our educational help. And then when they get at that level, this is where I'm going to introduce the educational content as a means to help them achieve their goals. Because if it helps them achieve their goals, it thereby has value. And they care about it, and they want to learn it, they want to excel on it. I'll show them how they can do problems that are more complex as a result of it, or achieve higher performance than they were able to before. But ultimately, I want to help to impress upon them they can outperform what their previous expectations were. And to be clear though, I do go all the way back to the basics to show them how they can do simple things that before better, faster, easier than they did before, and then build them back up to that. In order to keep them hooked, I'll also use traditional kind of gamification elements to provide what we call candy, any kind of incentive for them, which could be ways of achieving higher scores, different badges, different aesthetic enhancement rewards, whatever it might be to get them. But one of the things we found most effective as part of this was showing that they were making progression towards a goal. And let me give you a simple example of this. I might start out by telling them the maximum score that they could possibly earn in any of these challenges might be up to 900 points. If they keep on working all these challenges, they can earn 900 points. And so they work through the problem, trying to achieve this goal, and they have this idea, again, maybe I got about 815 points out of that 900, and at this point, I reveal to them that, hey, you've done well enough that you're ready to go to the next level, and now you can achieve up to 4,000 points. Holy smokes, I thought 900 points was the maximum I could do. Now you're telling me I can get 4,000 points? I never even considered that possibility that I could achieve something that great. And that's going to make me want to work that much harder. So if you follow these basic steps, you too can make a really big impact with gamification and edutainment as a whole. All right, let's layer in kind of some of the next level, because everyone talks about AI. So let's kind of give first, though, a basic understanding where AI in education is today. And largely, it's being focused on scalable, personalized help, but within certain limitations. Let me give you an example. So currently, the main approach is we try to map any kind of bad answers to mistakes being seen, such that, again, if I'm able to, if I give a very bad answer, the AI can suggest what mistakes to look for. This sounds like a pretty simple kind of AI mapping kind of problem, and it is. But just to make sure we're all clear, as a simple example, if I had the problem 2 minus 1, and a student put in, I don't know, the answer 3 for this, all right, the AI should be able to come back with a good response and recognize that 3 may be the outcome if the student accidentally added instead of subtracted. And it might be able to provide a hint saying you should check your operator. Maybe if it wants another hint, it might provide a definition or examples of subtraction for the student to go. And it might even go as far as showing how they can work out the problem for them. Although there are certain people who will argue that you should never really go that step, because otherwise our students won't think for themselves. And we don't want that to happen, right? We still want them to have that kind of skill set. But in general, these kind of AI approaches are pretty applicable whenever there is a definitive correct answer, very non-subjective as part of those, and you can make a good correlation between the mistakes and observable outcomes. And so it's typically only practical for situations where the educational material is going to be used often and by large groups as a whole of that. And so, although AI is definitely a tool that is helpful, it is by no means the solitary answer for helping out in education. It's a great new tool that we can offer educators in order to deal with some of the more basic common problems, but we still need teachers who are very experienced. And why is this? Well, as many of you may also recognize, the truth is AI is far more A than it is I. And a key part of intelligence, actually, or human smarts, if you will, is that we are really good at adapting to new situations. And we can help out students in many different situations. And again, I'm sure many are familiar with this, but just for the broader audience, if I have, let's say, some kind of AI, we know we can train it to do things like try to figure out what color something is. If I give it different color samples, tell me what is the actual name of that color, and maybe I can train it up to be 97% accuracy, and I'm feeling pretty good about that. But then if I give it something new that hasn't seen before, such like, let's say, color pink, we might expect or hope they might return something that we would expect and adapt our knowledge to say, well, it's actually red. But the AI might come back with something that says yellow, actually. Not at all what we would anticipate or expect as a part of those. Because the danger is always that how AI originally solved the problem is largely unknown to us, which can lead to very unexpected and in some situations very dangerous results as a part of that. And so, although again we can build it up as a good tool, when we move outside of the scope of what that tool is designed for, we can run into problems. And so we cannot rely on this solely for education. And I know there's a part of us all, in this audience who say, but it just means it's not good enough AI. I could do better. Because I saw it in a movie. There's a part of us that wants to believe so bad that there's more to this than what is actually there as a part of it. But we have to recognize that AI is a tool just like any other tool. And as much as we recognize that AI isn't the full solution for education, we must also educate our students in AI and recognize that we do not accept AI results just blindly. We have to recognize far more to it. And like even taking a look at the example that we have here, when we're feeling very good about that 97% accuracy, what happens with that other 3%? Depends upon the scenario that I'm doing this as to how severe the consequence could be. And so we need to help to teach students that not only can AI be used in a lot of situations, but it's an imperfect tool like any other. And we need to help them to recognize that I have to be able to ask situations like, can I identify the situation that I'm asking AI to solve that won't work appropriately before the AI is asked to handle it. If I can do that, that might be an okay situation to apply AI. I want to make sure that people are also, can I understand that the AI has done things in an undesired way? If I'm able to do that, okay, that's a safer scenario as well to provide, to use AI in. Or the other thing we should teach, again, is helping students recognize that I need to have some way of assessing that are the remaining consequences small enough that if I do get an undesired response, it's still going to be acceptable. But even in situations such as, a poor response, that we hope that could be easily identified by a user, it could also possibly lead to misinterpreted or larger issues. A simple example even being internet search misinformation. And we know the spread of misinformation is something that is potentially very dangerous in anyone. And again, I'm a strong believer of the power of what AI can do, but we need to also teach these three basic rules for being able to check whether or not this is a safer way to apply AI in for any situation. And again, this is coming from somebody who even builds Star Wars inspired robots in the lab all the time. Okay, so we've talked about edutainment, how to use that effectively, some of the pros and cons of using AI in education. Let's talk about making these things even be more effective. And for this, I'm going to go back to an opportunity. I got to be part of the Obama's CS for All initiative, part of the kickoff for this. And one of the interesting pieces of information I took away from working with this group is that it turns out if you try to teach computer science education, largely based upon just mainly screen-based techniques, they were seeing about an 18% completion rate at best. However, if you threw in real-world elements, let's say like robotics, which are actually tangible, they were seeing 75% completion rate. So take everything we just learned and adding in a real-world element really has a big impact. And let's even further. So if you took a simple robot like the one here and have students try to, again, to apply this to whatever situation they're learning, even if we add all the gamification elements, they're going to experience even more as a part of this. Because if I'm trying to have them do any kind of AI as a part of this, they are going to basically develop solutions that have to handle those unexpected situations, because nothing's ever going to be perfect in the real world with your robotic like it might be perfect in just that simulation. So students develop the skills and recognize the importance of dealing with these unexpected expectations. They also recognize how devastating that potential 3% can be, and recognize, I do need to be able to check to see whether or not my AI can handle the situation before I give it to it, and just trust those results as a part of it. I want to be able to catch it if it makes a mistake. And these are really critical elements. And so again, this helps to teach students that AI is one of many tools that are out there. And as I want to help people to be able to do these kinds of things, if there's one resource out there that I point you to that is doing a great job in robotics education, First Robotics Competition is a great example. And for those of you who may not be aware of it, this is an amazing group where across the world, between students and volunteers, there are over 1 million active participants worldwide across 190 countries. And they're finding that 81% of the students involved in it go on to pursue 4-year STEM degrees, and 83% take on leadership roles in their careers, because they really, again, are able to adapt their knowledge to real-world situations and make that difference as a part of it. I'm putting in here a couple links, and hopefully you'll be able to have access to these slides or links afterwards, and you can learn more about this program. But even that little robot that I mentioned before is a great place to start. This is already available in beta form, and there's a lot of great organizations that have been a part, including Spark Fund, First Deca, and others up here who are really helping to make this robot be available for even less than the cost of a K-12 textbook to an educator, which is amazing. And if you're interested in learning more about this, getting involved with First, overall, I encourage you, to reach out to CTEC or Azure Robotics as a resource for those. Okay, but we can take things even one step further in really helping our students. And let me give you a simple example of this. So, again, I love AI. I want to try to solve a problem. Here's a problem, let's say, that you may be familiar. I have a train that has to accelerate from 0 to 370 miles per hour in a certain number of seconds. It's going to, say, travel from Beijing to Shanghai as a part of this, and I have to solve some problem of this. And so if I'm an AI person, I immediately start to say, I can start to learn how the controls of this train really work and come up with the best way for this train to operate as a part of this. But if you're a really good designer as a part of this, you should really take one step further. And this is what we need to start to teach students. You should start to ask questions about this and say, why is 375 miles the maximum speed? Where did that come from? why not go 400 miles per hour, right? I can come up with a far better solution. Or wait a second, is 400 miles per hour actually too fast? Is it unsafe? So maybe I shouldn't even go 375. Maybe I should go 350 instead. Where did this number come from as a part of this? In fact, as I start to think about it, I'm like, why do I even have a train in the first place? What is it transporting? If it's transporting, cargo, maybe a train isn't the better solution. Maybe I should actually have separate factories that are in Beijing and Shanghai, and that will help to reduce the transportation needs significantly. I don't even need the train as a part of this overall. So why was a train even chosen? That's the level we want our students to be able to think about this, to be real problem solvers. Because in the end, the people don't care so much about how a problem is solved. They need just their problem solved in the best way possible. And so even if we might start out with an idea of a train, we need to have the skill set to be able to question that and how we even formulate the problem. Because again, yes, we can have AI solve this, but are we even having the AI solve the right problem in the first place? And this really emphasizes the need for computational thinking as a part of all the educational elements that we do. And so, as a quick summary, I did an effort where we looked at a lot of different kinds of people's work in the area of computational thinking and boiled it down to 10 major skill areas that are really fundamental as a part of this. Unfortunately, most computer science education is only focused on 2 of these areas, programming skills and algorithm development. But as I even just gave with the example of this train, being able to do basic challenge definition, performance definition, decomposition of problems is so essential as a part of this. Because the truth of the matter is being a designer isn't just about being a programmer anymore. There are very critical computational thinking skills that to be creative, bringing effective solutions that are applicable to nearly every major career field. And this isn't just me saying this. This is an entire body of work being done by many people. In fact, from Digital Promise, which is one of the largest organizations here in the United States that focuses on computer science education, talks about it's important for helping people think more broadly and design thinking skills to help them to be able to understand the complexity of systems that are become ubiquitous throughout our world. Being able to work more creatively, being able to work across teams as a part of it. It's even important just for us to be even a good global citizen, as technology plays an important role. And they go so far as to even say that computational thinking will be key no matter what career youth end up in. And unfortunately, we're pretty much at the end of our time, but if you're really interested to find out even more about this, again, I encourage you to reach out to these groups to find more. But hopefully together we've taken a look at, again, how edutainment can be even used more effectively. AI plays an important role, but it is not the end-all solution. There's more we need to teach as a part of it. But things like robotics, working with FIRST, and computational thinking are really the skill sets we need to build in order to help our next generation be even that much more effective at solving the complex problems throughout our world. So again, we thank you all very much for your time, and we hope to make an even bigger impact together with you all. Thank you.
Truly fascinating. Thank you. We extend our gratitude to Professor Schneider for his insightful and thought-provoking presentation.